Alright, so we're looking at question number 15 from the MAC 1140 Pre-Calculus Final Exam Review. It's asking us to solve the rational inequality and express the solution set in interval notation. We're given the rational inequality x plus 12 times x minus 5 divided by x minus 1 is greater than or equal to 0. So to start, we're going to go ahead and take the numerator. We're going to take each term by itself and set it greater than or equal to 0. And then we're going to take the denominator and set it equal to 0. Now we're going to go ahead and start with our first term from the numerator, and we're going to isolate x. To do so, we're going to subtract 12 from both sides, which leaves us with x is greater than or equal to negative 12. Next, we're going to do it to our second term in our numerator. We're going to add 5 to both sides to isolate, and that'll leave us with x is greater than or equal to positive 5. Lastly, we're going to look at our third term, the first one and only one in our denominator. We're going to go ahead and add 1 to both sides, which leaves us with a statement that x cannot equal positive 1. Now that we have those, let's go ahead and draw out our number line. Now that we have our number line, let's go ahead and put in our x values. First we have negative 12, then we have 1, and then 5. So I'm going to go ahead and choose some numbers in between each of these points to test so we can get our solution set. So for this one, I'm just going to do negative 20, then I will do 0, 2, and 6. So now let's go ahead and start testing these numbers. For x is equal to negative 20, let's plug that in. So when you go ahead and you plug in the negative 20 into each spot where there's an x in our original rational inequality, you get this statement. So let's go ahead and simplify this. When we simplify it, we get that when x is equal to negative 20, you get negative 9.2 is greater than or equal to 0, which is a false statement. So we can go ahead and label that in our number line, that this segment is false. Now let's follow the same steps for x is equal to 0. Now once you plug it in, let's go ahead and simplify it. So we should get 12 times negative 5 in the numerator, negative 1 in the denominator is greater than or equal to 0, and this will simplify down to negative 60 divided by negative 1, which gets us 60 is greater than or equal to 0, which is a true statement. So we know for this interval, it is true. Repeat for x is equal to 2. When you simplify, you will get 14 times negative 3 in the numerator and 1 in the denominator, which will leave you with negative 42 is greater than or equal to 0, and that is a false statement. So we know for that, period, it's going to be false. Now lastly, let's do the same steps for 6. When we reduce the numerator, you will get that 3.6 is greater than or equal to 0, which is a true statement. Let's go and label that in our number line. And now that we have our number line labeled, let's go ahead and highlight the key portions that are true. So from this, we can see that from negative 12 to 1 is true, and from 5 to infinity is true. But we know that based off of our x values up here, that x cannot equal 1. So this means that at 1 there will be a parenthesis, and at 12 there will be a bracket because it's greater than or equal to, and at 5 will also be a bracket because it's again greater than or equal to. So when we write this out in set interval notation, we get that negative 12 to 1, parenthesis, 5 to positive infinity, parenthesis. And that is going to be your final answer.